All right, guys, this time we're going to be talking about portfolios and we're going to find the optimal portfolio in terms of the Sharpe ratio or the Sharpe ratio, whatever you want to call it. And also, we're going to be finding the portfolio which has the safest, I mean, the lowest variance portfolio, so the minimum variance portfolio, the safest one for you. So we're going to be talking about some investment that is pretty uh, um, rewarding of taking a certain risk, because building a portfolio always comes with a risk. And there is another one that we're going to be building, or we're going to be having the percentages, the allocations, just in case you wanted to just go ahead and go for the safest haven that you could. For that, we're going to be using cryptocurrencies, as you see over here. Let me just, oops, sorry. So I downloaded this from Yahoo Finance, but you're just like free to, download it from whatever you want. I went like, Yahoo Finance and typed BTC, USD, and then I took the data for the last 5 years with in a monthly basis. That's what I did. So we start off with 2019, and since one of them, and I don't remember which one, could only had quotes from May the 1st, so that's the chosen date. So the thing is that you're gonna have to make them fit. All they should be having the same values. So that's one of the conditions to build this. But aside from that, well, that's pretty straightforward, and I believe that this is not gonna be very difficult for you, I believe. And if you have any problems, just go ahead and type it to me on the description below. I'm gonna leave this spreadsheet on my coffee, remember, where you can buy it at a certain price, at a price that you want. I'm gonna be leaving it at $5, but you can pay whatever you think it's worth, or whatever you can help me with, or if you want to invite me a coffee, well, I thank you very much for that. And don't forget to drop a like and share this video. It'll be very helpful for me. So let's just go ahead and start. Okay, so the first thing that we need to do is to find the returns of each of the cryptocurrencies. So it is usual that we use the log, the natural log, but you can just go ahead and like do like traditionally. But this is like what you should be doing, instead of just going like, let's do this for BNB, final value minus initial value over in close parenthesis over initial value. That's both of them are just as valid, but I think this is a better way to do it, using the logs. So let's just go ahead and use that one real quick. Sorry. Here, and then down to the very end until it kind of goes crazy. Thing is that I skipped the last value, to make room for the, make this more presentable. So I included a column. So this column wasn't there because I just wanted to, double click it. Well, never mind to that. Okay, so that's it. This is basically it. Those are the returns, and if you don't want to see them like that, we'll just go like this and add a few zeros here. Okay, let's select this again, and that too. Yeah, that looks a lot better. All right, now we're gonna be finding out. We're gonna find out what's gonna be the average return. The average return of each of the returns that we just found for each of the cryptos, and this is what we got. Okay, so you can see the formulas for the first one, for the first row. All right, and now we're gonna be calculating, I forgot to put this, x minus the x average. That's what we're gonna be doing. Let me just format this real quick. for you. Won't take very long. So for that, you're gonna be just like going equals this value, and then we hit twice F4, so you can lock it in. You can lock the average in, and then just select that and hit enter. This is how we just scroll down, and you see you can't double click if you got a bunch of stuff here. See, until it like turns into error. Wait, I have to go a few more. Let's go a few more. There we go. If you go like that, it's gonna take, you know, it's gonna be just the same. This one, yeah, okay, all right, yeah. So let's erase that one, the last one. All right. So if you double click here, you see that you're doing the last row, the last value with the average for BTC, and the same goes for Ripple and stuff. Yeah, I use those cryptocurrencies because I thought it was pretty much worth knowing if this is gonna be like a good investment or not. Let me erase this space. I hope it doesn't screw up anything. No, let's do it like that. Let's just shrink it a little. Shrink this column. Yeah. Okay. Great. Okay. Now we're gonna be building the variance covariance matrix, and that's gonna help us out to find several things that you're gonna be looking at here real soon. So for that, you just go ahead and equals mult, then transpose. We're going to be transposing the following matrix, which is this one, the one that we just built. Okay, we close the parentheses and comma, and mult, by the way, means matrix multiplication. So that means that we're going to be multiplying two matrices. Now we close this up, divided by open parentheses count, and we're going to be counting the values, the number of rows that we have, because that's going to be equivalent to the number of values that we're going to be getting, -1, because this is on terms of a sample. Okay, so now this is very important. Now you have to press at the same time Shift, Control, and then Enter, and you got this. And this is the formula we just did. Let me open it up a little so you can see over there. Yeah, let's save this real quick here. Okay, great. So that's the variance covariance matrix. That's gonna help us out to find the variance of the metrics of the portfolio. Excuse me. So the average return. I'm just gonna link this up. Wait, wrong. Okay, I'm gonna link this just this so I just don't get redundant. Save time. And then the variance. Let's check out the variance. So var.s for each of the cryptos. This is gonna make this is gonna make sense in a moment, because I wanna help you out find something that it is not it is relevant, but yeah. Well, okay, while we're at it, just go ahead and check this out. You know, the variance for Bitcoin, it's gonna be the same as the variance for Bitcoin. I mean, whatever it crosses Bitcoin with Bitcoin, you get 0.0436944, and this is what you get when you find the variance for Bitcoin. And now for this one, let me just go ahead and color it out. I'm gonna be coloring it out for you. You know, I'm a fan of coloring stuff, so you can show you what. There you go. So you see that the colors match the results that we got for each of you know, I mean, for Litecoin, for ADA, for Stellar, Lumen, for Monero. Okay, so stuff, and you know, as you know, that's the standard deviation, that's just the square root of the variance. So that's pretty straightforward. Okay, so that's the weight, and I'm not gonna call it weight, I'm gonna call it allocation, because this is a more adequate value. And since we got like, well, okay, how many are they? 8. So let's start off with an even number over here. Yeah. Okay. What? I've got a fraction. Okay, I'll leave it like that. Okay. I'm gonna put it over here, and I'm gonna be adding this up in the end, because this has got to add up to 100%, as you can see here. Let's turn this into percentage. There you have it. Okay, so this is the correlation matrix that's we're gonna be doing here. This is not critical, and this is not gonna change anything to the exercise in hand, but I thought it was gonna be a good thing to show you. So you select all the cells, and then you just select the variance covariance matrix, and divide this by the mode. And I'm gonna be I'm gonna transpose the standard deviation vector multiplied by itself. And once again, when you select several cells, what we have to do is Shift Control Enter, and this is it. All right then. Okay, so as you can see here, the one is right in the middle, right in the intersection between the cryptos, and this kind of tells us a lot of things. This is very different if you try to do this with the raw data, because that's what it tells you. There is something in physics that it's different, that I kind of like see it this way. In physics, you have something that's called the translation. Okay. Let me do my best. Okay, one thing is the road that you take to go to a certain place, and some other thing is how you move from one place to the other. You can take several rows to get to the same point somewhere else different from where you are. And if you take the straight line, or if you just like go back and forward and stuff, and it takes a lot of time. So this kind of tells you what was your initial state and what's going to be your final state in terms of the return. But the trajectory, that was the word that I was looking for, is the one that you do using this method, but using the raw data without using the values, the returns that we did. Okay, so let's not waste any more time here. This is pretty straightforward. This is you can find the description, what the correlation between two cryptos are. So let's just go ahead and go for. Okay, next we're gonna be finding the expected return of a portfolio, and for that, let me just erase this, because we're gonna be having a problem over here. By the way, I think I didn't copy this. Let me just go ahead and copy this real quick here. What Z? I think let me see if error. Yeah. Let me put this over here. Okay, I think this is gonna work. This is gonna work better, because I want you to know, I want you to see the formulas that I didn't I think I missed out. I mean, like if you go like this, 1/2, well, that's going to 1/some or something. Well, you're gonna be able to see it here. Now let's just go ahead and do this and not waste any more time. So let's find the expected return of the portfolio. So that's some some product of the allocation vector times the average return. There you have it. Okay, now for the variance, you just go ahead and multi. And then we select the allocation vector, and since it is horizontal, we don't have to transpose it. Now that times multi the variance covariance matrix, okay, comma, transpose the allocation vector. Shift Control Enter. Yeah, sure, whatever. So that's the variance of a portfolio, but I think it didn't work. Oh, sorry. Okay, drag it down here, and then you can see the. Let's see if I can merge this one just to get you the formulas. Okay, great. Yes. Weird. Okay. Now, the standard deviation. Well, as you can see, as you can probably figure it out, it's gonna be the square root of the variance, and that this I'm having troubles with my mouse. Okay, whatever. Okay, now the risk-free rate. Let's talk about the. Since those are cryptocurrencies, I believe we're gonna be talking about what you can get in a fixed, in a flexible account, perhaps in a DEX or maybe in Binance. I think for Bitcoin, which is gonna be like our risk-free instrument, what you can see in real life to be the 10 years T-bills for the US. So that's basically moving on to 2% or something. I believe this is like 2%. Yeah, I'm not gonna charge you anymore. And the Sharpe ratio, that's gonna be start off with an equals your expected return minus your risk-free rate, which I believe it's a lot less, but whatever, and the standard deviation. So yeah, let's try this to be 1.5. I think I saw it to be 0.34, even lower or something like that. And even if you do that, I'm gonna be raising a few numbers here. Yeah, and this is not percentage. It should be taken as percentage, or well, maybe it is. I mean, the interpretation for the Sharpe ratio is that what excess of return are you getting in terms of the risk that you're taking. That's basically what the Sharpe or the Sharpe ratio is. I mean, it's like we're doing 2.66% for every 1% in risk that we're dealing with. Okay, so let's save this out. And now let's find out the allocation for the optimum Sharpe ratio. Right, so let's copy this. I'm gonna copy the titles. Doesn't make any sense. I'm going to type it over again. We're gonna be doing the allocation here. Okay. So for that, we go to the solver. We go to data. We go to the solver. And then let's reset all. Yeah, let's reset all. That was something different that I did. Okay, so for the optimum Sharpe ratio, we're gonna be setting the cell, the Sharpe ratio, to be the maximum possible by changing the cells in the allocation here, and under one constraint, and that constraint is that this cell should be 100% because we're not considering short selling, not just yet. Okay, so add this. Okay, yeah, cancel them. Okay, so we have that. There we have it. Okay, let's go ahead and solve it. So we fire, and this is the best we can get, and that's the allocation, the best allocation possible, you know, for to get the maximum reward for the risk that we're taking. Here, yeah, a few of them are not like advisable, not even Bitcoin. Okay, now this is for the optimum ratio, and now let's look for the minimum variance portfolio. So for the minimum variance portfolio, we just do the same, but only considering a few things that should be different. Of course, this cell, the variance or the standard deviation, whichever you think it's better, it's okay. To be minimum, by changing the cells, we already have that. Yeah, those are the cells that we're gonna be changing. Yeah, and the constraint, that's the same constraint, so let's just go ahead and solve. We got an answer, and the answer was everything but a few things should be different here. So let's put this in terms of percentage, so you can see what the difference is for an efficient portfolio. All right. Okay, there are a few things that we should be like doing, like building the or getting the graph for the efficient portfolio. This is gonna help us out to get us with the initial portfolio. So let's just go ahead and do that real quick. Hope you're not tired, but well, okay. Let's start with this. Okay, so the expected return for the minimum variance, that's gonna be 6.77. There is something to keep in mind. What's gonna be the average return, the highest average return of all the cryptos? I think it's Matic, so 7.48. So we keep that in mind because we need the values for the standard deviation until we get very close to everything turning out to be 0 and this turning out to be 100. I mean, to get the highest possible return. Oh, let me show you with an example here. I'm gonna be adding like 1% now and then until we get here. It is impossible for us to get 7.67. So let's change that to 7.4. Yeah. Okay, so let's get the standard deviations here. Okay, for that one, I'm gonna copy and paste it as numbers, as values. And now let's use the solver again. Yeah, get the maximum and set the objective. I'm gonna be using this, the expected return, to be the maximum possible. But I'm gonna be adding a constraint, and that constraint should be that this value. Oh wait, sorry, that's wrong. Let's cancel. Let's cancel. Okay, I have to go for the minimum variance. The minimum variance, and that if this value, the expected return, is higher or equals to 2.67%. Okay, and solve. So you copy this and paste it as values. Okay, so you do the same with this one, and let me just go ahead and do this one again before I like fast forward, so you can like check this very quickly. The only thing that's gonna be changing is the number here. I'm gonna be using 3.6%. Okay, and fire. I'm gonna be doing this for the rest of the values, so hang on. Yeah, well, I was like making a mistake here, and I was checking my work and checking the numbers over here, and something didn't match. And the thing is that I was picking the variance value, and I should be getting I was supposed to be copying the standard deviation value. So let's just go ahead and do this for the last one. See how easy it is to get lost here. This is 7.4. Wait, 7.4. That's okay. And solve. That's maybe this deviation here with the highest risk of all time. Yeah. All this. Okay. Here now, insert. Let's use this one. Yeah, and then let's select the data here. Put it over here. All right, let's select the data. So add for the x value, we're gonna be having the standard deviation values. For the y, the expected return. All right, it's nice. Okay, so this is the efficient frontier at which we're gonna be working on. I mean, the explanation for this is that you could have different, like say, this goes like this. I'm gonna see that you're gonna see this in the next video that I make. It goes like this, like a Z-shape kind of graph, and you can see that you can have several percentages or several allocations that are gonna be providing the same risk. But the only ones, the efficient frontier tells us what's gonna be the best allocation possible for us in terms of the risk and reward. And the Sharpe ratio, the values of the Sharpe ratio, which are here, this allocation belongs to the cell over here. I mean, it might be like over here. And that tells you what's gonna be the best allocation in terms of the risk that you're taking, and that's kind of like diversifying the risk, the total risk, not the intrinsic or the extrinsic risk, but the whole risk. And this is why I use the Sharpe ratio instead of some other options that we have to find this optimal portfolio. Okay guys, so this is it. Don't forget to drop a like and share this video. If you want to go to my coffee site, well, I'm gonna leave you in the description below. I'm gonna leave you the link if you want to invite me a coffee or download this spreadsheet, well, I'll be very thankful. That way you'll support my my channel, and I thank you very much, and I'll show you love and stuff. Yeah, but don't forget to drop a like and share the video. I'll see you later. Bye bye.
I have to go and boom boom. Let's go. Put guns. Gata mata hoeteru motherfucker. 相手にできない。夢から覚めない。いつからこの性格 I don't mind。ならば来れば自分がなけりゃ流される津波。ミキサーお前のせいで。レベラフォロワーやっぱりお前のおかげで。右見て左見て右見て。ほら全てが幻。舐めたきゃ舐めとけ。代わりにゲロ吐く。I have to go and boom boom. Let's go. どこへ Put guns. どこへガタまた吠えてる motherfucker。 相手にできない。迷える子羊たくさん目に間にそれでも懲りずに貫くべき金本だらけ間にお気持ち程度で I got a music keep on moving Dang 見えないゲーム Day by day楽しいことyeahそれだけじゃねえ足りないんだねほら全てが幻舐めたきゃ舐めとけ代わりにゲロ吐く I have to go and boom boom Let's go どこへ Put guns どこへガタまた吠えてる motherfucker 相手にできない